G'day everyone, this is Peter Mammarella here with Millie's Flying Fish Thingo Part 4. Today we're going to be doing a body heading test using not raw data but calibrated data from our MPU 6050. So I have scaled the raw Z-axis gyroscope data. I've left the gyroscope sensitivity at the default value, which is plus or minus 250 degrees per second, which seems to be giving me really good results. And so yeah, that scale factor is 131 least significant bits per unit. I've converted the raw data to degrees per second and then integrated the sum of the measurements with respect to time, the time interval, and I seem to be getting really nice results, which I'll show you in a sec. A little bit about my setup. So I have my laser pointer attached to my tail there, and the tail heading is aligned with my body. So we can see there that we know that the laser pointer is giving us the heading for the body. I've printed this heading diagram down here, which measures from negative 45 degrees all the way around to positive 45 degrees. In this test, I'm basically just going to move the body from 0 to negative 45 to positive 45, and then probably back to 0, and we'll take a look at how accurate we are. We'll also have a look at the drift, which is a bit concerning. The acceptance criteria for this test is that the printed heading data matches with the actual heading. So I'm going to send my code to my fish. Just wait for that to upload. You can see we're bang on 0 there. We'll just have a look. So we're reading pretty close to 0. It's pretty good. 0.05 something. I'm going to move to negative 45 degrees, try and hold this really still. Bang on 45. And so you can see there we're pretty damn good. We're pretty close. And I'll spin that around to positive 45 degrees. And yeah, you can see we're pretty good at half a degree. Okay, now I'll go back to 0. Try and get this bang on 0, which is a bit difficult. Bang on 0. Okay, and so we're reading 0.1, which is pretty good. We can just watch the drift, just watch it kind of walk around there. It is a bit alarming. I have, it's actually not too bad at the moment. I have included a noise filter, which does cancel out the noise, which is great, but it doesn't help the drift. You can see that we're starting to walk around. It's not a great deal, but I think, it might cause issues. I seem to be having more drift when I'm on the battery pack and when I'm not on USB, which is a bit interesting. I understand from my research there is filters that you can apply to try and cancel out the drift. And those filters include using not only the gyroscope data, but also the accelerometer data. But unfortunately, given that I've mounted my MPU 6050 in this orientation with the Z-axis straight up, I'm not going to be able to use the accelerometer data because, gravity is acting along that Z-axis direction. So I can't actually use the accelerometer to determine the angle. So I'm just going to have to make do with the drift. It's not too bad, but it seems to be a lot worse on the battery pack for some reason. And I'm not going to be able to use this cable, the USB cable, when I do the next test because it's just too stiff, that cable. I'm thinking about actually changing the Arduino to a wireless Arduino so I can get some feedback, live feedback, just because the cable just doesn't allow the fish to really hold position. But anyway, we'll see how we go. So thank you.